All right, cosine functions is the topic of the day, and everything on this sheet is exactly the same as the sine sheet, except for line 4. And the specific difference has to do with the order of dots. So if we focus on the green highlight here, on the sine it was 0 top, 0 bottom, 0, and for this it was 0 bottom, 0 top, 0. Now we're starting at top or bottom, and then going to 0, and then switch to bottom or top. So basically the starting point of cosine is different than the sine, but they're the same graph. If we look at those graphs on our calculator at the same time, let's just clear this out. I'm just going to type in sine of x, and I'm typing cosine of x. So sine will be the blue graph, cosine will be the red graph. I'm going to go from a 0 to 2 pi window. That's our basic one period of each function. And let's go up by pi over 2. And then I'm going to go from -1 to 1, because that's the top and bottom of each of those graphs. All right. So hit graph and see what happens. There's sine starting at 0, going up, and gets back to 0 and goes down, and then goes back to 0. So our normal sine function is that. That's b is positive. Cosine starts at the top, then goes to 0, hits the bottom, then it goes back to 0, hits the top. So that's the normal cosine. So normal is positive. So if b is positive, it does the normal thing. If we had a negative in front of each of these, and we look at normal, sine's normal, it goes down first. So 0 bottom, 0 top, 0. So boto, right? The one we had. Now cosine negative starts bottom, goes 0, then top, then 0 bottom. So again, it's all based, step 4 is all based on what the original graph looks like. All we're doing to the original graph is we're stretching it this way, we're stretching it that way. So all the same features are going to be in the same order. Starts at the bottom, starts at the top, goes to the middle, goes to the top or bottom, and vice versa. So that's all that's happening here. All right. So if we consider that when we're graphing, everything's the same as it was with sine, but the difference is how these dots come about. Okay, I'm going to show you a couple of different things with the actual labeling of the graph that you might prefer to what you just did. If you don't, go ahead and go the other way. That's fine. What I showed you on Wednesday is fine. But I'm going to show you a different technique today for labeling your graph you might prefer. And I'm fine with that too. So, first off, axis to the left, y-axis and the x-axis going this way. I put 4 dashes on the y-axis. If you want to, I mean, if you do this, and just as long as I know what each of those dashes represents, you can do that. It's fine. All right. If you just want to put 1 dash, just label where the 1 is. That's what I basically asked for that. But let's just take a look at this. Y equals cosine of 2 pi over 3x. So first off, I can see that b is equal to positive 1. So the amplitude is 1, right? Also, the fact that b is greater than 0 tells me the order of dots, right? And I might even figure that out immediately. Well, it's greater than 0, so that's top, 0, bottom, 0, top. So it's tobot. All right. The other thing I can see, obviously, is that c is equal to 2 pi over 3, which means the period is going to be 2 pi divided by c. So 2 pi divided by 2 pi over 3 is the same as 2 pi times 3 over 2 pi. 2 pi's cancel, so the period of this thing is 3. That tells me that the scale that I want to use on my x-axis is going to be 1/4 of that. 1/4 of 3 is 3/4. So I'm going to go up by 3/4 on the x-axis. So that's the information I need to get from that, right? So I know how the dots are supposed to go, I know how high it's supposed to go, I know how the x dashes are supposed to go. Now it's a matter of labeling this thing. So, a couple things. First off, amplitude 1. That means this thing goes up to 1. So if I want to make 0.25, 0.5, 0.75, 1, I could do that. If I want to make that 1, I can do that. If I want to make it a half 1, a half 2, I can do that. Pick a scale. All right. Again, if you just want to put a 1 there somewhere, I'm just going to put a 1 right there. 1's up 4, -1's down 4. So I can label my graph the way I have it. This, of course, is 0. Going up by 3/4, so this would be 3/4 3/4 plus 3/4 is 6/4, better known as 3/2. 6/4 plus 3/4 is 9/4, doesn't reduce. 9/4 plus 3/4 is 12/4, better known as 3. If we end up at the correct number, if we end up there on our fourth dash, right there, then we know we did the right thing, right? So, we got top, 0, bottom, so it starts at the top, goes to 0, goes to the bottom, goes to 0, goes to the top, and then we connect the smooth curve. Make sure that cosines looks like this. It goes like that. Sine and cosine both go like that. What we're going is from here to here. So the very first thing it does when it goes beyond that point is it starts going back down. So make sure you start a little lower. Wow, that's not very good at all. My shadow got me. I'm going to try again. We're only going through one period, but you do want to continue the graph, the arrows at least the right direction. I've seen people they'll just make the arrow go off like that, kind of like it's a parabola. But again, what it's doing is that as it gets to 1, it starts to flatten out, then it wants to go back down because 1's the high point there. So again, that would be how to do it. We'll say that normally. All right. So let me just give you a couple variations of this that you might prefer. If you don't find that works just perfectly fine. I have no problem with you continuing to do it that way. It will be correct every time. The other option for labeling your x and y axis is to identify a scale. So let's say I got y at a 0.25 scale. Well, that sufficiently tells me what each of these dashes represents, right? 0.25, 0.5, 0.751. So I know where 1's at based on that. Similarly, if each of these dashes is signified by a scale, x is going up by 3/4. That sufficiently tells me each of those dashes also. All right. And I'm going to put a 0 here just to verify that's my starting point, because again, next time we visit this, we're going to be moving it up, down, left, or right. So that won't necessarily be 0 to start off with. All right. So if you give me that much information, tell me what this point represents. And if you put 0, I'm going to assume x and y both 0. Again, down the road, y might be 2 and x might be 3 pi right there. I don't know. So you might put, like, you know, maybe a starting point of x, 3 pi, and then let's say this is y equals 2. Now that's 2.25, 2.5, 2.75, 3, 1.75, 1.5, 1.25, 1. So again, just give me enough information so I know what things represent. And you can use these scales here, and whatever this number is what goes there. And again, you can make that whatever, as long as you know where that thing is at, you're in good shape. So 0 there, so that right there tells me everything. And again, top, make sure you pick the right one. So if this is 0.5, 1's there. If that's 1, 1's there. So make sure you know where the top is based on what your scale is. Top, 0, bottom, 0, top. Get the same graph. Let me just pick a couple difference here. 0.5, now 0.51 is right there, right? Top, 0, bottom, 0, top. Still right. If we have a scale of y equals 1, now that's 1. So that's the top, 0, bottom, 0, top. All three of those graphs are correct. The blue period for the blue graph, the red for the red, the green for the green. But again, take your pick. As long as your graph fits the proper amplitude, the proper spacing for your x's, you got your dots in the right spot, you're going to get credit for the right graph. So again, I'm fine with however you want to do it. I personally like to do it that way. That way I don't have all those numbers in the way while I'm graphing it. But you know, take your pick. They both work for me. What you did on Wednesday is perfectly fine. This is also perfectly fine.